G'day everybody and welcome back to the channel. As you can see, I'm about to start populating this circuit board up. What I think I'm going to do is I'm going to tin this area first. Instantly after we solder everything, we're going to use PCB cleaner to get all the flux residue off, because I don't want any flux residue, especially here where the screw terminals bite down. I know it bite through the flux, but I just like everything to be as good as it can be. Anyway, the other thing that wasn't in the schematic for the board, because it's going on the back of the board, and the reason it's going on the back of the board is because I want it as close to the terminals of the capacitor as it can be, is a 1 microfarad monolithic cap. So after this is on the board, we'll see what area is taken up by the heads of the screws, and then just next to that, like, you know, say there and there, for example, something like that, or there and there, probably will go there and there, you know, that will go on there. Other than that, that's it. It's time to start populating. So I'm just making this area in the middle nice and even. Screw it, I'll put it back. I was trying to take solder out to make it flatter, but it turns out it's easier to just do that. I've got to get some of that tinning stuff. I just want this relatively flat, only because the capacitor's screws go here. Yeah, that'll do for the capacitor bit. I'm not worried about tinning the rest of the board until it's done. I just wanted that so that I can mount the capacitor and see what I got for space. Also, it gives me a nice little way of holding the board once it's mounted to the capacitor. So I'm just going to clean off that flux and get it mounted. I'll just pause the video whilst I do that, because you don't want to watch me cleaning stuff. But you know what, I've got Q-tips right in front of me. I'll just never mind. I'll just do this. This stuff makes flux just turn to liquid like instantly. It's really good. Noting that our positive is here, by the way. What a wonderful capacitor. I'll just get a bigger screwdriver than that, because that's way too small. Yeah, big one. That is nice, and I don't know how you explain it. These little lock nuts bite down into the solder quite nicely. Every single one. even where it's slightly uneven because it bites in, and I did it up really tight. Yeah, and there's a little gap in between the cap and the board too. I like that. That's nice. Alright. We've got this guy. Now I just want to make sure that I didn't screw the pin out on this, because that's something I would do. Now these are... It's a good question. I don't have the data sheet up. I should have had that up still. Tip 41C. Let's see. Pin 1's base, pin 3 is emitter. Starting looking at the front. So that's base. Did I do this right? Yes. Collector, emitter. Beautiful. I did it right. Okay, I'm just going to go get the chassis because I need to know exactly how far off the board to solder that. Okay, something's already wrong. Oh, nope. Cool. Alright, well I've got to cut the pins down a bit already before I can even find out how long that needs to be. Looks like about there. Let me see if I can get this out without bumping it. Oh, I knocked it, but that's okay. I've got it. I'm just going to do this in situ. I knew that was going to happen. Why did you have to move? Alright. That's quite good. Ah, beautiful. Can't ask for more. Alright. Oops. Alright. Now, also got this here. Solder it in. Just make sure it's straight. Call that a win. Let's see. I'll start at this end, I guess. I think what I might do is I might get my schematic so I don't do anything stupid. What I might do is I might put all the components in off the camera, so because I'm going to sit here and look at the look at the schematic because I'm doing it upside down, and to be honest with you, I can't remember exactly where everything goes. Like I can remember just about everything. The one thing I'll probably get wrong is the bloody what do you call it, voltage doubler. I always manage to put the capacitors in the wrong way. I'm just going to grab my schematic. It's been a sensible thing of me to do. That's better. Right. So. Incidentally, I am reusing the capacitors that... Oops, wrong hole. Reusing the capacitors that I had on the breadboard for this. I think I might just populate it off camera and then come back and solder it on camera. It'll save you guys a lot of time watching me work out where everything goes. So as soon as I've done this, alright, I'll go work out where everything goes, populate it, come back and solder it then. Or maybe I'll time lapse it in little bits. I don't know, but I won't do it like this because this is just going to take too long. Alright, I've got a few components in for now, so we'll solder them in. Brilliant. Alright, we'll trim those legs off and get the next lot of components on. I'm only aiming it down at the table so that the legs don't fly everywhere. Hello, little man. Oh, my mouth's dry. That's what happens when you talk for too much. Alright. Little man. Yes. So that's that part. I'll go get a few more components mounted up and then I'll come back. Alright, well that's a few more things on, so you know the drill. I don't like that when I see a bit of trace it's not taking solder. I know I'm way too fussy. Alright. Alright. It's getting there. Cool. And don't worry, those resistors do not even get warm at all, so you don't have to worry about the capacitors baking. I would not put that like that. If they even got above room temperature, I wouldn't put them there. So that's the first empty spot that's left. That's the compensation capacitor, or should I say the shut up capacitor for the Zener diode. That's what I'm calling it. Yeah. This capacitor is going here, but that's already chosen. That value won't change, so I'll install that one. But all the others we will have to do looking at the scope. I think now I'm just going to start randomly placing stuff. I don't know why, but doing voltage doublers, especially upside down, it always racks my brain. I'm just forming the legs up on this transistor. Like so. Which way does that go? This way. You beauty. Alright. Starting to look like something again. I think I made the pin spacing for this resistor a little bit too tight. I think it'll just fit in there. Gotta always stand it up, but oh, it is honestly a bit tight, but it'll live. It'll live. Might just solder that in now before it goes somewhere. By goes somewhere, I mean pops out of place. For those that are wondering, I am missing the correct size drill bit, so all of these smaller holes are actually a size bigger than what I wanted them to be. All the other holes are the right size, but they're not too big. It's all right. Okay, so now we want well, I'll stick our base to emitter resistors in. I think I'll just start from here and work down. Alright. I just got to form up some more transistor legs. I think I'll just pause the video and populate the rest of the board quickly and then come back and solder it all up just to save time. I'm getting so absorbed in my own work here, I just stuck a transistor in and soldered it off camera. My apologies. I was going to go populate the board up off camera, and then I was like, screw it. I'll just start putting components in. Whoops. Screwed that up. Wait. What was I using a 4.7k resistor for? Surely not the base to emitter resistor. Oh. Whoopsie. That's the base to emitter resistor for the small transistor. I forgot about that. Oops. Bummer. I'm going to have to wait for my desoldering gun to heat up. I'll just pause the video again. Alright, so first mistake of the day. What should I say on this board? I don't know if I've actually made any other mistakes today. Can't remember. Now, we'll put our 4.7k resistor in here. Where does that 1k go? Zener, capacitor, resistor. It goes there. That looks like a standing up one. That's going to just go in the tub of random. That's going to go in the bin. That's got no legs on it. Never mind. 1k. Let's get another 1k out the drawer. Alright. Can I fit it in this way? No, that's definitely going to be a standing up one. Oh. I mean, I could put it in there just to keep with the style. You know, I'm going to go for it. I'm just going to have to fold the legs in a bit on itself. It's alright. It's not the end of the world. It's not perfect. But it'll live. Almost can't tell. Now, we want our Zener. Oh, I don't know which one of those Zeners is which. Could just read them. That is a 33 or 38. That's 42. Alright, so this is the one that goes the 5.1 volt Zener. Oh yeah, 4733. That's 5.1, isn't it? Wait, is it? Let me just double check. I don't want to put the wrong Zener in the wrong spot. 4733. Yes, 5.1. I was right. Alright. Now, the band has to point towards the emitter. I'm just pointing that out for people that are trying to do this at home or that are learning. I feel like that one's pretty obvious. The band's pointing towards where positive comes from, but this one for some people might not be so obvious. Might as well put our other Zener in. Now this one, I can't even work out where I am. Wait, what? Snubber, capacitor. Oh, the Zener goes. You know what? Oh, I know why I'm confused. I've forgotten to drill the hole for the Zener there. One moment. Alright, that's better. Thought something didn't add up then. Alright, so this Zener, we want it pointing. Actually, you know what? I'm going to put the 1N4 and 4/8. Yeah, I'm going to put the 1N4 and 4/8 first. Oh yeah, you know what? Where did I have the pot coming off of? Let me just pause the video and think about something. I might have done something wrong here. No, it's actually just me. It's actually exactly how it's supposed to be. I'm just not thinking straight. Alright, that does go there. And then the last Zener goes there. Now this Zener has got to point towards the positive terminal. Again, for people that are learning electronics, this one might be a little bit tricky. Probably not as tricky as the one that points towards the emitter, but still might be a little bit tricky for some people because it points towards the cathode, the stripe on the 1N4 and 4/8 diode. So you got stripe facing stripe. That is, of course, because Zeners conduct in both directions. One way is your Zener, the other way is a normal diode junction. Still feel like I'm missing something. You know what? Oh no, 1K resistor, that's right. I thought I got the wrong resistor value. I couldn't see where my 3.3K was, but I've already put it in. I was getting worried for a minute because I was thinking if I've put it in wherever I put it, I've put it in the wrong spot, you know. No, it's exactly where it's supposed to go. This resistor doesn't really fit here too. I made the tracks just a bit too short, but we can make it fit. I don't measure any of this, if anyone's wondering. I do this all by eye, and I don't even use the ruler to draw straight lines. I just do it all freehand, judge everything by eye. Don't measure component legs or anything. Like pitch, width, spacings, nothing. Just do it all by eye. So that's why it's not perfect, you know? Alright, so that is the entire circuit on there. What we have is we have space for a capacitor to make this shut up. Xena noise. And what we have here is a space for a capacitor across these two diodes, and a space for a snubber going from the base to positive terminal sense. Incidentally, the pads we have here are wiper, the right of the pot, the left of the pot, so that's where the pot goes. Positive sense, negative sense. This would be positive in, collector, negative in, negative out, and AC in. So that's that. So it's coming along. I did forget one thing actually. Excuse me. Sorry, this cold's got my nose and throat a bit blocked up. This one capacitor I want on the back. I don't think we have much space in the back. That's why I'm folding the leads so tight. I'm happy with that. I think I'll just pre-tin this one and just reflow it. It'll be easier. Alright, cool. I'm quite happy with that. I reckon that'll fit. Let's just see. Can't ask for more than that, can you? You guys can probably see straight down there, that whole lines up perfectly. And yeah, the capacitor fits because the cover goes over this. So actually got a bit of space on the bottom of the board. Right. Just be careful with that tip 41. Alright. I think what I'm going to do now is I'm going to start filling in traces, flooding traces. Then I'll come back and I'll give you a look at it. And then we'll install it in the supply, but not in the supply. With the extra long wires, we'll just tack the wires on the board so we can run it on the bench, because we want to get good access to put the scope on it, and we want to get good access to add compensation networks and capacitors. So I'll go fill these traces in now. I'll be back when that's done. Alright, that's the board with the traces all filled in. All we've got left, the little bits of copper that you can see around the place and the holes, that's where we've still got to attach the wires from the power supply and the snubber components. I've cleaned all the flux off, double checked that those are tight. This is ready to be, well, got to wait for that to dry, but there's still a bit of board cleaner. You know, I don't think sometimes. Still a bit of board cleaner on here that's got to dry off. But there's no flux on here anymore. Right. I'll just leave that off to the side to dry anyway. I'll just leave it right there. And I'll stop the video. When that's dry, I'll start soldering the wires onto it and we'll start compensation. So it's come to my attention that this video is already 45 minutes long, so I think I'll just upload this, and I guess it'll be a 7-part video. Because this is already about 45 minutes long and I don't want people to get bored. And I guess we have covered a little bit here. I mean, the main part of the product that I have redesigned is complete. Well, minus a few components. Literally only because they need to be chosen in situ. But yeah. So I think I'll upload this. You can all get a good look at it up close. I just want to point this out too. These wires, I've been thinking about this. I am going to cut these off. I know I never discussed this before, but I don't want a flat piece of metal in between these nice spiky lock washers that are digging into the solder and making really good contact with that screw, with these old, slowly dulling, oxidizing, whatever you want to call it, connectors in between. I'd rather just cut that, strip it, solder one wire there, solder one wire there, you know, just, yeah. So that's what I'm going to do with that. Try and be careful not to snap the legs on that LED. Yeah, and there's the top view for you guys. So that's the voltage doubler, Zener, regulator. I mean, it's just a shunt regulator, there's no transistors or anything. And then a crap ton of filtering. Then we've got our comparator with its emitter reference, the high limit slash feedback reference, and our Darlington stack up driving the series parts element. And this is our main dropping resistor that the collector drops its voltage on. As the collector, I will say this, what happens is as this transistor tries to pull the output down and it turns on more, what happens is it drops voltage across this resistor, but initially all the voltage drops across here. Then as the resistance gets lower in this path because of the transistor closing up, these capacitors will slowly discharge more and there'll be more volt drop across these resistors, and the volt drop across that will sort of come back up as go back down, sorry, as these come back up, but it will always be the same total volt drop. unless you went out of reason, say that was a really low value resistor and the really high value resistors were here, you know, you'd be asking the transistor essentially to shunt all the current that's in the capacitor, and you'd have to put a bigger transistor there. That would just be stupid, and it would also ruin the performance characteristics of the power supply. But like this, with a 3.3k resistor there, that's perfectly fine. Is it 3.3? Yes, 3.3. All right. I'll see you all in the next one.